Intermediate Algebra Review of Applications Final Assessment continued. Question number 6 has the instruction solve the direct variation. So for question number 6 it says, if m varies directly as p and m equals 12, when p equals 4, what is the value of m when p equals 8? So we're going to set up a direct variation here. So we have an m equals k times p. We're going to plug these values in. So I have 12 is equal to k times 4. I'm going to divide the 4 out off both sides so that I can find k. So I see that 3 is equal to k. Now that I know k, I can come back to the same equation with the m equals kp, and I can plug in 3 for my k. I can also look at this. It says, what is the value of m when p equals 8? Well, now that I know k, I can plug in the p value of 8 next to it, and I find that m is equal to 24. Number 7 says to solve. According to Ohm's law, the electric current I in amperes in a circuit varies directly as the voltage V. When 28 volts are applied, the current is 2 amperes. What is the current when 19 volts are applied? So we're going to set up a similar problem. This time we have our I, or current, over here with our variation with our K times our voltage. So we're going to solve with what we know to begin with. So we have 2 amps is equal to K times 28. So I'm going to divide that 28 out, and I end up with 2 over 28, which reduces down to 1/14. Now that I know K, I'm going to come back and I'm going to take that same formula and I'm going to plug that 1/14 in. And I'm going to use the what is the current when it's 19 volts. So I'm going to take the 1/14 times the 19, and I'm going to find out what that current is. I see that it comes out to 19 over 14. I could take this one then and divide the 14 into the 19 so that I get a decimal, which is 1.35714. I want to go ahead and round this number off. It doesn't tell me exactly where to round it off at on this one. When that happens, having a couple of decimal points will be sufficient. So I'm going to use 2 decimal places. So I'm going to come out here. I see that my 5 right here is going to be my second decimal place. Next to it is a 7, so I'm going to round that 5 up to a 6. So it's 1.36 amps approximately. Going on to question number 8. This time I have a pitch of P of a musical tone that varies inversely this time. So this is going to be a division problem instead of multiplication, like the other two. As its wavelength W on tone has a pitch of 352 vibrations per second and a wavelength of 3.4 feet, find the wavelength of another tone that has a pitch of 262 vibrations per second. So I know that this thing has a pitch of 352. So I have my pitch equals, right, and this time I'm setting up a situation where it's inversely, so I'm going to have the K over the W, which is the wavelength. So I have 352 equals K over 3.4. This time the 3.4 is dividing, so to get it to the other side I'm going to multiply both sides by 3.4, which is going to give me a 1196.8 equals K. Now I can plug that value in, and I can come back and answer the question at the end. It says, find the wavelength of another tone that has a pitch of 262 vibrations per second. So I'm going to plug in that 262 equals 1196.8 over W, or wavelength. Now the wavelength, I'm going to move it out first. So I'm going to multiply it to both sides. It's dividing, So the opposite is multiply, so I'll multiply it to the left, I'll multiply it to the right. That clears it off the left, so I end up with 262W equals 1196.8. The last step now is to divide out that 262 on both sides of the equal sign. Once I divide that out, I'm left with W, or wavelength, equal to 4.5679389, and so on. It just continues out. So I'm going to round this one off to the first decimal place, and I've got approximately 4.6 feet. Don't forget the feet, or the units. Question number 9 says, translate the problem to a system of equations. Then solve using the elimination method. So here, on question number 9, it says the perimeter of a rectangle, or a rectangular piece of wood, is 40 inches. The length is 10 inches more than the width. Find the length and the width. So I've drawn a picture over here of a rectangle, and I've put my information on here. I have length and I have width. When I look back, it says the perimeter of the rectangular piece of wood is 40 inches. So I know P is equal to 40 inches. The other thing I know is that the length is 10 inches more than the width. So my L is equal to W plus 10. So I plug that in there. Some other things that I also know is that perimeter of a rectangle is calculated by taking perimeter equals 2 times the length plus 2 times the width. I know that length is equal to W plus 10, so for the L I'm going to plug in a W plus 10. This creates an equation where I have a single variable. I'm just calculating width. So let's simplify it. I'm going to distribute the 2 through the parentheses, so I end up with a 2W plus a 20 plus a 2W. Now I'm going to combine like terms, continuing with the process of simplifying. So I end up with a 4W plus a 20. So now I've got 40 equals 4W plus 20. Next, I'm going to subtract that 20 off both sides. So minus 20 minus 20. I'm left with 20 equals a 4W. Last step is divide the 4 through on both sides. So I find that the width is equal to 5. So my width is equal to 5. If I look back at the problem, everything's measured in inches. So my width is 5 inches. My length was supposed to be the width plus 10 inches. So that means 5 plus 10 to create the 15 inches. Moving on to question number 10, it says Walt made an extra $9,000 last year from a part-time job. He invested part of the money at 10% APR and the rest at 7% APR. He made a total of $780 in interest. How much was invested at the 7%? So again, I'm going to come in here and make a table. I'm first going to use just the first column to indicate what my two parts are. So I have a 10% and a 7% APR. In the second column, I'm going to take those percentages and put them into their decimal form. So 10% in decimal form is a 0.1. 7% in decimal form is a 0.07. From here, now I'm going to look at what he invested into each account. So he had $9,000 to invest. And it doesn't matter at this point which one you pick on. I'm going to pick on the 7%. So I'm going to, I'm picking on the 10%. I'm just going to say that I invested X amount into 10%. Right? That means that his $9,000 initially, minus whatever that X amount is that he put in the 10, is what would be left for the 7%. So that gives me a formula for the 7%. So he put X amount in the 10%, and then if you look at it, that 9,000 minus that X amount, we don't know what it is, will be what was left to go into the 7%. Now I can multiply these across. The 0.1 times the X, the 0.07 times the 9,000 minus X, And the other piece of information that I know is that the 10%, the interest earned on the 10% plus the interest earned on the 7% was equal to $780. So this gives me a formula. So I have my 0.1x plus 0.07 times the 9,000 minus x equals $780. So let's simplify and solve for x. So first off, I'm going to distribute to clear the parentheses. So I'm going to multiply this 0.07 through. I end up with 630 minus a 0.07x. Next, I'm going to combine like terms. So I need to combine the 0.1x and the negative 0.07x, which leaves me with a 0.03x plus 630 on the left, still equaling to the 780. Next, I'm going to subtract the 630 off both sides. So when I do this, I'm left with a 0.03x equals 150. So my next step is to take that 0.03, divide it through the 150, and that leaves me with x is equal to 5,000. So that means that he invested into the 10% $5,000, but it asked how much he invested into the 7%. So I need to look back at the table. I saw in the if you look back at your table, you'll see that you wrote down that you have 9,000 minus the x. Well, we know that the x is what was in the 10% or invested in the 10%, which is 5,000. So we have 9,000 minus 5,000, so that means that he invested $4,000 into the 7% APR.